Hi guys, so today we're going to do 6.6. This is called special circumstances. I gotta get my notes out, sorry. Okay, so 6.6 solves special systems. So in this we're going to show you two different methods on how to solve the systems of equations. We've used all the same methods, but we're going to show you when something special happens after solving. So this up here for linear systems with no solution, the lines will be parallel and do not intersect. So when everything is parallel, that means that it will not touch each other. Sorry, it's hard to write. So parallel and do not intersect. We have two equations here, and we're going to start by using our first method. So we're going to graph. I'm going to circle my top equation, and I'm going to rewrite it. So I have negative 5x plus 4y equals 16. I want to get y by itself so that I can graph it. So I'm going to add 5x to both sides. So 4y equals 5x plus 16. And then to get y by itself, I divide. So I have y equals 5 over 4x plus 4. Before I graph, I want to know that my m is 5 over 4 and my b is 4. So they gave us a graph. I'm going to go ahead and start with my b. So go up 4 and put a point. Now my slope is positive. Normally I would want to go up and to the right, but since my graph ends here, I can also go down and to the left. So I'm going to go down 5, 1, 2, 3, 4, 5, right 4, and put a point. And that right there is going to be my first line. And now we're going to do the same thing with equation 2. So I have 5x minus 4y equals 8. I want to get y by itself, so I'm going to subtract the 5x. I get negative 4y equals negative 5x plus 8. And I'm going to divide everything by negative 4. So y equals a negative divided by a negative is a positive minus 2. So my m is again 5/4 and my b is negative 2. So I'm going to go to negative 2 and put a point, and this time I can go up and to the right. So go up 1, 2, 3, 4, 5, right 1, 2, 3, 4. If you notice, they're parallel, and we could tell that these lines are going to be parallel before we even graph them because their slopes are exactly the same. If you have two lines with the same slope, that means they're going to be parallel. So let's go ahead and try method 2, elimination. So I'm going to write my first equation, negative 5x plus 4y equals 16, and write my second one, 5x minus 4y equals 8. So now we know that we combine like terms going down. Negative 5x plus 5x is 0, so my x's eliminate. And 4 minus 4 is 0, so my y's eliminate. So now I have 0 on the left side of the equal sign. And if I add down, 16 plus 8 is 24. Well, I know that 0 does not equal 24, so this statement is false. And down here it says the variables are eliminated and you are left with a false statement, regardless of the x and y values of x and y, excuse me. This tells you there is no solution. So if the graphs do not intersect, there is no solution. If the variables do not equal or cancel out and then don't equal each other, there's also no solution. Let's try another example. Go ahead and flip over your notes. up top it says, for a linear system with infinitely many solutions, the lines will be the same. And we're going to do two examples again that's going to show you what that's going to look like. Method 1 is graphing. So I have my first equation. I'm going to write it. So y equals 2/3 x plus 5. And I want to state what my m and b are. So my m is 2/3, my b is 5. So I am going to put a point at 5, and I go up 1, 2, right 1, 2, 3. That's my first line. It's kind of short on this graph. And I'm going to do the same thing for my second equation. So I have negative 2x plus 3y equals 15. I want to get y by itself, so I'm going to add the 2x over. I have 3y equals 2x plus 15. Then I divide everything by 3. And I get y equals 2/3 x. 15 divided by 3 is 5. So if you notice, again, my m is 2/3 and my b is 5. That's going to be the exact same line. If it's the exact same line right on top of each other, it's going to be infinitely many solutions. So this down here says the equations represent the same line, so at any point on the line is a solution. So the linear system has infinitely many solutions. That would be my answer. Let's look at it by doing substitution. So I have my first equation, y equals 2/3 x plus 5. And my second equation, negative 2x plus 3y equals 15. I'm going to take what y equals and I'm going to substitute it in for y in my second equation. So I have negative 2x plus 3. I'm going to substitute in 2/3 x plus 5 equals 15. I'm going to distribute my 2/3, so I have negative 2x plus 3 times 2/3 is positive 2x. 3 times 5 is 15. Now if you notice, I have a negative 2x and a positive 2x. Well, negative 2 plus 2 is 0, so those are going to cancel. And I'm left with 15 equals 15. Since those are the same numbers, that is true. This down here says, once you use the substitution method and you are left with a statement that is true regardless of the values of x and y, this tells you that there are infinitely, and I'm not going to be able to fit this all on this line, infinitely many solutions. Okay, I think we have a couple more things that we're going to do really quickly. So on the back it says, now you try. So we have 2x minus 4y equals 4. So I'm going to rewrite that. On my second equation, I'm going to get x by itself. So I'm going to subtract the 2 on both sides. And now I have x equals 2y minus 2. So I'm going to take what x equals and I'm going to plug it in for x in my first equation. So I have 2. Instead of x, I'm going to write 2y minus 2. Then I have minus 4y equals 4. Distribute. 2 times 2 is 4y minus 4 minus 4y equals 4. I have a positive 4y and a negative 4y. Those are going to cancel. And I'm left with negative 4 equals 4. Those are not equal, so this is false. And my answer would be no solution. Okay, let's try this bottom one. So this is an elimination problem. So I want to combine like terms down. Negative 9x plus 9x is 0. Those will cancel. 6y minus 6y is 0. Those will cancel. So I'm left with 0 on the left side. 21 minus 24 is negative 3. 0 does not equal negative 3, so that again is false. And if we write false, our answer is no solution. Okay, couple more things down here. So to tell whether the linear system has one solution, no solution, or infinitely many solutions, here's what you need to do. So if it has one solution, that means that there's one point that the lines intersect at. If there's no solution, that means that the variables dropped out and then whatever it equals was false, or it means that the lines are parallel. And if it's infinitely many solutions, that means that whatever you get, one side will equal the other, or the lines are the exact same right on top of each other. So down here, for example 3, we're just going to tell if there's one solution, no solution, or infinitely many solutions. So over here, we're going to start with this first equation, and we're going to get y by itself. So I'm going to subtract x from both sides. So I have negative x minus 4. That means that my m would be negative 1 and my b would be negative 4. For my second equation, I have y equals negative x plus 1. So that means that if I were to graph it, my m would be negative 1 and my b would be positive 1. My m's are exactly the same. So since I have the same slope, my lines would be parallel, which means no solution. My slopes are the same, my y-intercepts are different. All right, number 2. I'm going to get y by itself for both of these. So I have 4x plus y equals 2. Subtract the 4x. Y equals negative 4x plus 2. So my m is negative 4 and my b is 2. Do the same thing for the second equation. So I have 4x minus y equals 1. Subtract the 4x. Negative y equals negative 4 plus 1. 4x plus 1. Divide everything by negative 1. So y equals positive 4x minus 1. So here my m is positive 4 and my b is negative 1. So my slopes are different. That means that my lines will intersect and I will have one solution. Okay, let's do one more. So start with my first equation and get y by itself. So I have 2x plus 2y equals 4. Subtract 2y equals negative 2x plus 4. Divide everything